Okay, folks, we can get started. Thank you very much for coming. We're excited to present this topic. So to make sure you're at the right place, the name of the session is called Is Your Enterprise Data Lake Metadata-Driven and Secure? This is a comprehensive topic, so we're going to focus on one aspect of it. You'll probably have more questions, and we'll try to address them at the end of the session. But we've got a lot to cover, so we'll get started while people are milling about. So this is the disclaimer slide. Throw it up there. And this is the agenda. We're going to have a quick introduction. We'll give an overview of Apache Atlas and Ranger, and then we'll get to the exciting part. We'll actually give you a technical preview, and we'll try to get you a brief demo. Right. And then if we have time, we'll try to address your questions. The schedule's a bit tight today, so if you have questions that we're not able to address right after this session, both Marin and myself will be available afterwards. Okay. Gain some weight.
Sorry?
We gained some weight.
Yep.
Okay. So here's the overview. I'm not going to go through all the aspects of the slide. We have other sessions. This is a shameless plug for the other sessions that I have where we're going to talk about Atlas in depth. Really, we want to talk about the Atlas Ranger integration. So in-depth discussion about Atlas, I definitely extend the invitation to come to a different session. There'll be another one today and tomorrow where we can talk about different aspects of Atlas. Suffice to say, can I see a show of hands of folks who might have who have some knowledge of Atlas, just to kind of level set? Well, that's actually quite good. Atlas, in a nutshell, is about metadata, and what we want to do is use metadata in the HTTP stack to really orchestrate and coordinate the activities inside. As you know, there's a lot of components inside of Hadoop. There's over 30 at last count. Just to add some rigor and be able to marshal your efforts efficiently, we want to bring them all together, and at least in terms of data lineage, operations, and discovery, to be able to do that in one place, and that's Apache Atlas. So what we're going to talk about here is how to leverage that to provide dynamic security, right? So that's the metadata-driven portion of it, and we're going to talk about new ways to secure your data, right? Some quick concepts: metadata scalability. The data lake has a lot of new opportunities and possibilities, right? This potential comes with a number of new problems, and a lot of it has to do with scale. So as your data grows, you'll need new ways of managing that data, and that's really what we're trying to talk about in this slide. You're going to need a new set of tools that are metadata driven, right? And we are an advocate of using tags for this purpose, and we're actually going to talk about that specifically, right? Okay, there are 4 types of tags that are going to be released in this upcoming release, which will be in the summer of this year. It's going to be tag-based policy, geography-based policy, time, and prohibitions, right? We're going to focus on only one today for the demo, but we can talk at length about the others if you wish. So let's start off with the geography-based policy. This is really being able to map an IP address to a specific policy. So the policy can be written once and dynamically adjust to the different environments. So this can be used for things like data domicile rules, where data cannot leave or be accessed in certain types of locations. As long as you resolve the IP correctly, you can take care of those compliance concerns. Additionally, if you have certain types of data that need to be protected from remote users, you can map certain policies to a specific VLAN or a proxy IP, so those are possible. Time-based policies are based upon expiry, so this is different from removing data, right? This is a kind of a gentler way to do that, so this will help you with management of quotas and just making sure that processes that may be running are not going to be stopped abruptly. This is really helpful for management of quotas from different customers, chargebacks, and things like that, as well as other types of compliance requirements such as SOX 90-day reporting for certain types of data that's garnered from the internet, for instance. The last one is prohibitions, and this is kind of an interesting one. This is going to stop a good actor from making a mistake, and it's done at the data access layer, and this allows us to provide a prohibition against a combination. So certain columns from different tables or different databases, we can prevent them from being put together in a SQL statement, right? So atomically, those elements might be okay, but if you aggregate them, you can discover some sensitive data that may not be allowed. So we can write a policy for that. The last one, which is actually first on the list, is the tag-based policy, and that's what we're going to show you today. So here we can tag different types of assets, and that metadata will correspond to a policy in Ranger, and now we can enforce access based upon that tag. So really, the benefit here is that you can scale out this model. You can have different curators, many curators, data domain experts, classify data and tag that data. But you can still have one place to manage policy and audit that activity, right? So that's the breakdown. So as I mentioned, Atlas provides metadata. Ranger is going to provide access and entitlements, right? Okay.
All right. Okay. So before we started, I asked how many people are familiar with Ranger. I've seen only few hands raised. So I'll spend a few minutes going through what Ranger is. So Ranger is Apache Hadoop component which provides centralized authorization right now for about 8 components. So what do I mean by centralized authorization? So if you take a few examples like HDFS, Hive, and HBase. So in HDFS, you give authorization by going to the command line and do change mode and change owner. That's a way you control access to HDFS files and directories. And if you go to Hive, you would be using grant and revoke statements. You say this finance database is accessible by finance department users who are in finance group. And then each table within the database, you can have different ACLs. Similarly, in HBase, you would go to HBase shell, you would give a similar grant and revoke statement to control access. So each of them require you to learn different way of access, specific access control. There is no unified way from a single place where you would be able to specify accesses. That's the first part. The second part is about audit logs. So Ranger provides audit logs for any access happen to your Hadoop resources in a centralized place where you would be able to query. So this particular user, what files he accessed during this time frame, or what database tables and columns have been accessed. So all of them you get in a centralized place. So we'll go through some of the examples of Ranger admin console. You'll be able to see what authorization policy looks like in Ranger. And so there are 2 kinds of authorization policies available in Ranger right now. So one is resource-based policies, wherein you pick a specific resource or specific set of resources. Let's say in HDFS, you pick a folder, HR folder, and you specify which users have what access on the folder. And specifying resources, Ranger has a few easy ways, like you can specify wildcards. You can say HR star, HR slash, and anything under that folder. So you can specify at a very high level. So you don't have to go at individual folder level, individual file level. And similarly for databases, you can use wildcards to specify what columns or what tables some user has access to. For example, you might have a database for test purposes, which may start with test as a prefix. And you can give permission for everyone for the table which start with test. This is one of the examples. So similarly, for other type of components, like if you take Kafka, you can specify which topic has specific user and what are the topics they have permission to publish or consume. These are resource-based policies, wherein you pick a set of resources and you pick set of users and groups and what permission they have on it. And then the second type is what we are going to see today is classification-based security. So wherein you don't pick a resource to specify access control, you pick a classification of a resource. The classification can be a PII, it's personally identifiable information, things like your social security number or bank account number or anything which can identify a person. And there are regulations, requirements, so what kind of users have access to this specific data, like PCI, PII, PHI. So in this model, the way it works is there's one set of users who classify the data in various components like HDFS, Hive, and HBase. For example, in Hive, there is a table which has your employee number or SSN number. You'll be tagging that particular table or particular column as PII, and any user who is running a query which accesses that row will automatically be applied the access rules defined for PII. So in this case, you don't go and pick for individual resources. So you just pick a tag and specify access for that. And we use a similar tag-based policies for another use case which Andrew talked about, expires on. So basically you can have data which expires on certain day, and beyond that day, only certain users should be able to access the data. So if there is some finance data which is accessible only like 7 years, then you would tag the data with expiry tag and you put a date on the tag, and then when anyone accesses the data, the tag will automatically prevent users from being able to access it. So we'll look at these two use cases. If time permits, we can go and see a few more use cases. So just a overview of Ranger. So the way Ranger works is, so there's an administration portal where you would go and create access policies, and those policies are stored in a policy store. And for each component which enforces Ranger access policies, will have a plugin, and that plugin enforces the policies you define in Ranger admin portal. Then the plugin also generates audit logs as access happen, and that audit log is stored in audit store. And Ranger currently supports 4 different audit stores. So one is Solar, HDFS, RDBMS, and Log4j. The audit log in Solar and RDBMS, you can look at use our Ranger admin portal to interactively query what kind of accesses happen on a specific resource by a specific user. We'll see a quick demo of that. And the HDFS audit log, that can be used for long-term storage. You can store it and you can write a Hive table on top of it. You can query on it. And Log4j is one mechanism. A lot of customers have found way to take this audit log and put it in their custom audit store. So this we already seen it, I guess, right? So this basically shows how Atlas and Ranger integration works. And do you want to?
Sure. I think we talked about most of these components already. This is just a relationship of how we get data into Ranger, kind of along the lines of the other slides we showed. You know, the data, the metadata originates in Atlas and it makes its way to Ranger through a notification framework. We're actually going to show you this, so I think we can skip to the next.
Okay. So for this demo, we are going to take this simple use case. There are 2 users, one user and analyst, and another user admin. And we are going to talk about 2 tags. One is PII, and the other one is called expiry. And we look at those use cases. So the user analyst should not be able to access the data which is tagged as PII. And that user should not be able to access data after the expiry date specified in the tag. Okay. And user admin should be able to access data which is tagged as PII and also should be able to access after the expiry date. So we'll see these 2 use cases. And we have chosen Hive as a resource for this demo. So there are 2 databases and 2 tables we'll consider. This first database, the finance database, it's got a table called tax 2010. And there's an expiry date associated with this table. It's 12/31/2015. And any access after this date will be denied for most users except the ones which have been explicitly authorized. And the next one is there's a database HR table employee. And this employee table has SSN column, and this column is tagged as PII. And this tagging is, by the way, done in Apache Atlas. And when the user tries to access this specific column, the analyst user will be denied, and the admin user will be able to access it. And all these accesses will be audited in Ranger audit log. We'll take a look at those audits as well. Okay. I'll do the demo. Okay. So you want to walk through the Atlas part first?
I'll do that.
Okay.
Okay, so there's a lot of different components to Atlas. And I'm not going to go through them at this point. You should come to my other talk. There's another plug. So here we have, this is a prototype UI. We're actually going to have a bit more in terms of development there. But here we can do a search for PII and find out what tags, what the tags are associated with. We can also do a search on the tag expires on, and we find that it's a Hive table, and there's a specific one that we'll look at here. Now, in Atlas, we can define tags, and these are authoritative tags that are used for the entire stack, right? So while you can use them for assets in Hive, you can also use them for other supported components, right? So that's the whole point of using tags, to have that scalability, and that's really what we're after here. In this example, we're going to only address one. But in Atlas, as you can see, we provide lineage dynamically. If you mouse over them, you can get the details of this. And we'll go through this in another session that's going to be on later today. But what I want to do is point to this area here. We dynamically capture schema, and you can see that the column SSN, so Social Security number in the US, is a personally identifiable information. So we added this tag. If we wanted to, we could have added many other tags. They'll be listed here. But for this purpose, we only need one, right? So that's really what I wanted to show you here. Now, this information, as illustrated in the previous diagram, will go through some mechanisms by which it makes its way to Ranger. We have a notification framework. There's a number of topics we publish to. Ranger picks it up, and it does some magic to make sure that's very efficiently integrated into its cache, right? Okay. So at this point, we're going to flip over to Embari, and we're going to show you the access with
okay.
Hive view.
I want to show the Ranger policies first.
Oh, sure.
Okay. Let me go through the Ranger.
There you go.
Okay. Right. So let's take a couple of minutes to go through the policies. Since most of you are new to Ranger, I'll spend like a minute or two on the Ranger policies. So this is the admin console where security, the person who is in charge of defining access policies would come in. And as you can see, there are multiple components listed here: HDFS, HBase, Hive, Storm, Knox. So each of them have different set of resources. If you take HDFS, the resources, oops, what happened? Okay, it's back here. Okay, so if you look at HDFS, the resource is a file here, resource path, and this is a typical structure of policy in Ranger. This is going to be repeated for any other type of component. There are only few changes. So the top side, top part of the policy, you specify what the resource is. And since in HDFS it's a directory or file, you specify a path, and you can give multiple paths here. So, and it supports wildcard, and you can specify whether the policy applies recursively from that directory on, or is it to a specific directory only. And then the bottom part is about what users and group and what kind of access they have. So you can pick a user admin, and whatever users in the cluster, you pick a user and pick what kind of permissions they have on this particular set of resources here. And you can have multiple such users and groups for different set of permissions. And this model is consistent across all the components. So that's why we started saying that Ranger provides centralized authorization mechanism. So let's take a quick look at the same thing for Hive. So the Hive, the resource definition is different here. You talk about database, table, and column. And then the type of access you have in Hive are different than in HDFS. HDFS talked about read, write, and execute, whereas in Hive it talks about select, update, create table, drop, alter, index. So there are different kind of accesses depending on the component to which the authorization policy is getting built. So these are all resource-based policies. So that's going to be similar for every component. If you pick Yarn, it's going to talk about queues. And if you take Solar, it's going to talk about collections and so on and so forth. So this is resource-based access control. So now what we talked about is the tag-based access control. That's what we are going to go through demo. So similar to resource-based policies, there is tag-based policies. The structure of the policy remains same. Let's pick this expires on. So you first give the name of the tag for which you are defining the access control. And then you pick what users should be denied or allowed access to. So in this case, you see that there is an allow and deny as well. So Ranger policies do allow you to pick certain users and groups or conditions to which the access should be denied. So in this case, for any resource tagged as expires on, okay, so this policy basically, whenever resource is accessed after the expiry date, this is the condition. Okay. In the Ranger speak, public is everyone. So everyone will be denied access. Anyone accessing data tagged as expires on will be denied access after the expiry date. So the expiry date comes as an attribute in the tag. I'll just show you in Atlas how you specify attributes for the tags. And then there is an exclude condition given in the deny. Here it's the admin user. The admin user will be excluded from this deny. That's how this policy is written. So now we'll quickly go. Sorry? Ambar, yeah. So now we'll go through this one use case. We'll look at the demo. So I'm logging in as a user analyst, and then let's go to high view.
And high view is basically what we're using for anything that's going to be generating SQL. So this is just for this demo, but if you have another application that sits on top of Hive, obviously these set of permissions would work for that. And that's actually a very important thing. A lot of times security for Hadoop is application specific, but this is platform or data access layer at the access layer. So basically anything that sits on top of Hive will be governed properly.
Okay. So remember, currently I logged in as a user analyst. I'm trying to access a table in tax 2010 in finance database. And this table is set to expire on 12/31/2015, which is like 3 months back. So now this user should be denied access to it. So they get a message that the user doesn't have a select privilege on this table. And this error message is pretty standard as what you would get in Hive today if you run in command line. We try to get the same message from Ranger as well. And we'll quickly look at how the audit looks after we go through the scenario. So now let me try to access another table.
Yeah, so you'll recall in the setup that the analyst does not have access to PII tag either. So get the same.
Right. So you can see when the analysts tried to access SSN column, they were denied. But let's say they tried to access ID, they should be able to access it. You see that result here. Okay. So we'll quickly look at the audit log then to see what's happened here. Then I'll also show you access by an admin user, and both of these access should be allowed because they have been explicitly given an exception in Ranger policy. See, this user is able to look at the contents of the table. Same here. Now the query went through and user is able to see the results here. So now we just saw the contents of the expires on policy, but I just want to quickly show the policy for PII, which is very similar. You pick a tag, in this case PII, and pick the condition in which it should be denied. In this case, the public, which is everyone, should be denied access for any operation on Hive, and the admin user is excluded from the deny, and that's why the user was able to access it. So now we'll quickly look at the audit log here. So you can see that this is the audit, interactive audit. Oh, once again we lost it. So this is the interactive UI in Ranger admin to look at the audits of all the accesses happen in the cluster. So in this case, we started access by an analyst user to this table, finance table and tax 2010. And you can see that the access was denied. And it records that this access had, there's an expires tag associated with this particular request. So suppose if the user accesses multiple tables or multiple columns and each of them had different sort of tags associated, all of those tags you will see here. So this is one powerful way for you to look at all the accesses which happen to a specific tag. You can go to Ranger audit interface and see that. And it also provides an interface to look at what policy actually did the deny or allow. So in this case, the access was denied by this particular policy. So it kind of closes. So you can look at when access has been allowed, again you can go and look at which policy allowed. So this helps you to troubleshoot in case of some users complaining that I was denied access, then you'll be able to go and look at the policy. And in case security audit, you can again go and see which policy allowed and then tune that policy. So this user was denied because the user didn't have access to expires on tag. And similarly, when the user tried to access SSN column, and they were denied as well. But this was denied by a different policy. We just saw through this policy details, this policy PAI. And then when you look at the admin user was able to allow the access. Even though the tag expires on was attached with this resources access in the query, the user was allowed to access. And similar way, you can see that the user was able to access the employee table, even though there was a PA tag associated with that.
Could you turn
All right.
this mic, please?
Any questions so far? Yes.
Can you hold on for
One second. Yeah.
We're recording this, so we just want to make sure that you speak into the mic. So you're going to be famous.
Can you show us how you create the tag, the tag policy, please?
Even tag policy or tags?
The tag.
Tag, okay.
Yeah.
So remember, there's two parts to this. The creation of the tag itself is done in Atlas, and then the policy is then attached in Ranger. And the reason why we do that is because you can go to tags.
So let's see, you want to pick a column which is, let's say, the business number. You want to tag this column as SSN. Yeah. Okay. You want to go through that or should I?
Yeah, go finish it.
Okay. So I was just going to show in Atlas how you create a tag.
So there's two ways to do it. But the easy way is to create a new tag definition here. And as you create them, you can create new attributes here. So you can create region, for instance. You can create as many as you like. So this is what we mean in terms of creating an attribute for the tag. And once it's created, you will see that shows up here. And now when you go to a data asset, you can go ahead and make that association. It's very important that we do this in one place because the whole point of having an authoritative taxonomy is to have it in one place, right? So that's what we're doing here. Now once we create it, we can use it in many different places. So Ranger is able to secure different types of resources. So we're able to use this tag for any of those resources. So remember, resource-based policy is a group of people being mapped to a bucket of stuff. Now we're taking that group of people and mapping them to a tag. So we don't have to write explicit policies for every asset in that component. So we wrote that policy that you saw for anything inside of Hive, not a particular table or a database, right? Did that answer your question?
Yeah.
Great. Another question? Wow.
And just let me finish this just quickly.
Go ahead.
So how you associate a tag with a specific table or column, right? So you pick this column, and then tags. Actually, this screen is not showing up full here. Give me a second. And then add tag, and you pick a tag, and that tag is added now. And it makes its way to Ranger via Kafka notification and all. And next time anyone try to access this particular column, and any policy associated with this particular tag test, in this case, will be applied automatically.
So
Yes.
for the types of the tag, so could the user define their own types? For example, not just time, possibly by size of the file or size of the data?
You mean dynamically?
Yeah.
Okay.
Tag or something.
So one of the things that we capture is, and we'll talk about this in another session, we dynamically capture statistics about the metadata from certain components such as date created, date modified, or that kind of stuff. We automatically capture that, and that's a part of an attribute. You can create custom tags, but to populate those tags, that's something that you'd have to create some custom reporting on, but you can do it.
Does this mean I have to write some code or write some?
It depends on what you want to do. Size of file, I think we already captured that, but there's other things like, there's a whole slew of data quality, data profiling measures that might be specific to a database appliance that may not be generalizable. So in those cases, you have to write some custom code.
The second question is if I possibly, if some field is possibly is denied, can I get partial data? For example, select star, but I still get some part of the data.
Right. So that's one of the often asked questions, especially in the context of Hive. That doesn't work because in Hive, when somebody gives a SQL query, they expect that many number of columns to come back, and that's how the JDBC interface works. So we will not be able to return only the columns which users have access to, because it just doesn't comply with the JDBC model. But in terms of HBase and all, they do support model where the return data will have less number of columns than what is asked for, and the programs are returned that way. So it's possible to do it in HBase.
Okay.
Yes.
I think we're actually over time, so I'm going to just take a few questions, but you can, we'll definitely address questions you have outside. I think they want to go.
So further questions? Yeah.
Okay. I wasn't keeping track. So. Okay. We have time for one more after this one.
Where does the authorization actually take place? Is it the component that delegates to the Ranger plugin?
The Ranger plugin runs within the component, so the authorization happens within the component itself. So it's not going out or making any REST call and all. It's making within the component itself.
It's pretty efficient, and we can talk about the architecture of it.
Is there one more question?
One more question, and I think we're going to wrap it up. I think I was here. Sorry, I apologize.
Which components of the Hadoop ecosystem are supported by tag-based policies? So you have shown Hive. Are there any other components?
So right now, only Hive, I think, is, Andrew, you can correct, but right now, with the Ranger integration, only Hive is available. But the integration is open, so it should be possible to support any other component which can be tagged.
Yeah, we started with Hive because that was, obviously the component that's used most. We will be extending that to other components. We can talk offline about which ones. I can't publicly say which ones we're going to address next. We'll have some nice surprises for you by the summer of when we have a summit in San Jose. Okay. All right, thank you very much for your time.
Thank
Really
you.
appreciate you spending a few minutes with us. Thank you very much.